So in this next lecture segment, I'm going to talk about biodiversity measures. The first measure that I'll introduce is measuring biodiversity over time. Can we really measure biodiversity though? In a perfect world, we would measure all species, all living organisms around the world over time. But of course, that's not possible. We don't have enough resources to collect the information on all organisms. We have other measures though. We know about differences in gene sequences. We know about species richness in different ecosystems. We know about different functions that organisms provide in an ecosystem. Although I have a footnote there that those sort of measures don't fully capture all the variability, all the functions, all the quantity and the distribution of organisms over space and time. Let's go to one measure that measures biodiversity dynamically. That means over time. And that's the Living Planet Index. The Living Planet Index is calculated from trends in global population of mammals, birds, reptiles, and amphibians and fishes. Those are all vertebrate species. It's collected by the WWF and it covers more than 14,000 populations of more than 3,700 species. Massive amount of data collected to create this Living Planet Index every 4 years, I think it is. What I'm showing you is the most recent report that came out in 2016. So what is this Living Planet Index? It measures population size, density, and abundance of these different species over time. The data collection began in 1970, so that is now 47 years ago. And when you download the report, you will see that most populations for which data is available have declined over time. And this Living Planet Index shows you that globally biodiversity is in decline. So how is it calculated? This Living Planet Index works as follows. They first look at the annual rate of change, which I call ROC, rate of change, for each individual population. So individual population of a vertebrate species. And the rate of change is the difference in populations over time divided by the time that has passed. So annual change, how many of population do we have in year 2 minus how many of that population did we have in the previous year divided by 2 years. Pretty self-explanatory. But I'm showing you the different notations to familiarize you with different scientific notations. So P2 is population in year 2 minus P1, population in year 1, divided by year 2 minus year 1. Which is also delta P divided by delta Y. The delta means the difference or the change. And then there is a more generic notation where I just say Pj minus Pk, where J and K stand for different years. So we calculate this annual rate of change for each individual population. And then take the average change for each species for each year since 1970. And what they then do is they just add them all up to see whether, on average, species populations go up or go down. So let me walk you through that process. They've calculated the rate of change for each individual population. Then they add them up, they aggregate them. Aggregation just means adding up. And they aggregate it for different types of systems. One distinction is between tropical and temperate systems, and another aggregation is between marine systems, terrestrial systems, and freshwater systems. So they're just two different classifications that are collected. Once they have all that information, they add those up again, so tropical plus temperate, or marine plus terrestrial plus freshwater, to calculate a global living planet index. So there you go. A little bit of a schematic how that is done. You see that they have multiple species. A species could consist of multiple populations. And then different systems, terrestrial, marine, and freshwater in a tropical or a temperate climate. And they add that up to tropical and temperate, which makes a global living planet index, but also those three different ecosystems, terrestrial, marine, or freshwater. Hi guys, sorry about that. I got interrupted by a student. So let me just recap that we were talking about the Living Planet Index, where you could have multiple species, and one species could have multiple populations, different areas of the world. They get measured, their annual rate of change gets documented, and then all the different species get added up into different systems, either terrestrial versus temperate, or either tropical versus temperate, or terrestrial, marine, and freshwater. And they get added up to get a global living planet index. So what affects biodiversity? And why is it reducing? Well, the key threats to biodiversity at the moment are habitat change. So deforestation, for example, conversion to cropland, urban development, climate change, overexploitation of forests or fisheries, pollution, which is also affecting species habitat. And over the past years, we've seen a massive decline in biodiversity. So what I'm showing here is the trend in the past, in the previous Living Planet Index, which was released in 2012, which shows a decline in global biodiversity. In 1970, we started with a value of 1, which gives you the base value, the reference value. And you can see that over time, that white line here, biodiversity is going down. So we have a negative rate of change. In fact, we've lost 58% of our global biodiversity in those 42 years of data collection. That's massive. So in this graph, you can see multiple things. You can see the decline, but you can also see this, the spread. This spread is an important concept in statistics. It shows you the variability in measurement. In the Living Planet Index, it shows a confidence interval around that average trend that they've calculated. So keep that in mind, because it will come back. Now let's unpack that global living planet index a little bit into the different systems. We had terrestrial, marine and freshwater systems. Terrestrial, the land organisms have gone down by about 38%. Freshwater systems have gone down nearly more than 80%. That's huge. Whereas marine has gone down by about 36%. And you can see that, for example, in the marine systems, by the end of the 1980s, the decline has kind of stabilized. That's because by that time, global agreements on fishing and fishery exploitation came in, and maximum sustainable yields. But why would freshwater have such a large decline? Why would freshwater systems have suffered so much over the past 40 odd years compared to terrestrial systems? Well, that's because freshwater is suffering from cumulative impacts. Freshwater habitats are not just impacted by what's happening in the river itself, but it also accumulates pollution and other effects from the wider catchment that flows into that river. So if anything changes in the river basin, in the catchment, it will affect a freshwater system. So they're impacted by dams, by pollution, by invasive aquatic species, urban development, water extraction, which cumulative has resulted in a massive decline in freshwater biodiversity. In addition, rivers and lakes often cross administrative and political boundaries, which makes it very difficult to manage them. So it's a bit of a sad story here. There's lots of things you can look at in the Living Planet Index. They have reduction in global diversity by region in the world, but I just thought it would be interesting to show the change in biodiversity for different types of countries. This is from the previous Living Planet Index in 2012 that was released. And they had this image for different income countries, low income countries, middle income countries and high income countries. We are a high income country. And what you see is that in low income countries, biodiversity has declined much steeper than for high income countries, for example. Why would that be? Think about that for a minute. Why would high income countries see an increase in biodiversity since the 1970s, whereas middle income and low income countries have seen a decline? You know what? I'm going to have a break and let you ponder that question.